So this is kind of, we haven't done a lot of this, I guess in a long time. It says write the equation of the tangent line. And I guarantee you that will be a question that is asked at least once, maybe 3 or 4 times on an AP exam. So what you have to know is one form of writing the equation of the tangent line is you need a point and you need a slope. All right, we're deciding that part. There we go. So the big connection in calculus is what is slope? Well, slope is derivative. Derivative is dy dx. So there's your slope. But we need a slope at the specific point. I need the slope at x1, y1. I'll grab one there. So they give us the point that we need. So here's x1, y1. And all I need to do is I need to find the slope at that point. So sometimes you'll see people put a line and put like a 1, 1 here. So you're evaluating the derivative when x is 1 and y is 1, which is just 1 squared or 1. So there's my slope. It was plugging in the given point, and just whatever the differential equation told me to do with x and y, that's what I did. So there's my slope. This is going to be real annoying if it doesn't work like it should. And then what do? We are going to write the equation of the tangent line. We know that x1, y1, which is the point, I plug in 1, 1. And technically, you could stop there. That's your equation of the tangent line. However, it asks us to do one extra thing. It says approximate f1.2. So what I would do then is I would just simplify this and distribute the 1 move the equation over, and this ends up being 0. So there's my equation for the tangent line. But remember how y is actually equal to f of x. So that is also the equation of the tangent line. And now that we have that, let's just plug in 1.2. And that's how we're going to approximate that answer. Really friendly numbers. But that's what they're going to probably ask you to do, is they're going to give you a differential equation, they're going to give you a point, and you have to find the slope, use the point to write the equation of the tangent line, and then once you have that, you can use it to approximate any value. It's a very common theme or practice type problem you'll see. Okay. I'm going to pause. Well, actually, I won't pause the video. We have to have a quick talk. I know you guys probably can't see this awesome right now. But we got to talk about the AP test really quickly because you guys have 2 options. So if you're on Zoom right now, pay very special attention to make sure you can hear and see everything perfectly. If not, let me know. So students have to select one of 2 options to take the AP exam. And that option is going to be either in person or a digital test, which will be online, and those will be on 2 different dates. And I want to make sure you guys make the best decision for your needs. So what we have here is all digital exams must be completed from home. So if you are taking the at-home option, please make sure you understand that you're doing that at home. But all of the versions of the tests will be full length and cover the course's full scope of content required for college credit, which means which means that you will be, everything we've covered is fair game. And there's one big difference between taking it here at Tartan or at home, and I'll talk about that in a second. So students who decide to complete the AP exam digitally must ensure that you have a reliable internet access at home, and the exam must be completed on a computer or a laptop. You can't use a cell phone or a tablet or anything other than a laptop or a computer. I'm going to send you a little survey that has, you have to fill out, and I'll show you a little PDF here about the different exam formats. But calculus-wise, what are your two options? So you have the in-person exam, which is going to be May 24th at 8 a.m. here at Tartan. Okay. That is the one I recommend, and I really hope, unless you have some needs where you cannot come into Tartan, I hope everyone selects the May 24th. The other option is June 9th at home. So this would be on your own computer. What's the difference? They are going to be different formatted tests. Okay? All of the practice and AP stuff we're going to be doing is going to be really preparing. You will see a lot of styles that prepare us for the in-person paper exam. And that's where you just go through the text booklet, and there's 4 sections. There's a calculator part for multiple choice. There's a no calculator part for multiple choice, a calculator part for free response, and a no calculator part for free response. So there's 4 sections. Each one is timed. The nice thing about the in-person exam is you can go back if you're in, like let's say that you take the free response calculator part, and you're going through it, and you get through it, and then the time ends up. And they're like, okay, you're done, put away this. Okay, the next one would be then starting the no calculator exam, free response. Well, during that time, if there was something you wanted to finish up from the calculator part, just maybe justifying and writing it or checking your work, you can go back to that section and fix things. You just can't use your calculator. If you are taking the online test, and this is really important for everyone to understand, if you're taking the test at home, you cannot go back even from one problem to the next. So once you take a problem, it has to be finished in that order. So you have to do number 1, you have to do number 2, you have to do number 3. Basically, there's no going back. That is a huge, in my mind, that is a really big disadvantage. And they do that because they don't want students to use outside resources. And the other issue that I think is going to happen with and actually I think I have it down here, it is right here. So please note, if you choose the June 9th date, it says all at-home administrators will be delivered in a digital format. You must use a laptop, desktop computer, no cell phones, iPads, or other smart devices are allowed for use. So you can't use your cell phone. A lot of students, I know last year students were like, oh, this is going to be sweet. I'm going to take it at home. I'm going to have my notes up here and here. It didn't help them. It actually made things worse because some of the kids were trying to look through their notes and they were wasting time. Okay. The other thing is, and look at this last sentence, all written answers will need to be typed in, and you cannot write or submit any photos. So you can't do handwork like we thought you were going to be able to do. This is new to me. You have to type it all in, which means you're not going to be able to get a lot of credit for showing your basic steps. So if you know how to do all the work and show the work, but your justification isn't as strong, I think you should take the in-person exam because you get credit for showing your work and all the steps, and that's a regular AP exam. But for the the at-home one, you really have to be strong at justifying and typing your answers out. And I just think what would lead to more success would be taking the in-person exam. Now, do know that if you are worried about coming into Tartan, this will be in a large setting, probably the gymnasium. You'll be able to walk in, maintain proper social distancing. Everything will be sanitized. You'll be in a very safe setting. So I really hope that everyone kind of will choose the in-person exam. That's my advice. I think students will be more successful. If you do the at-home one, I think there's a lot of opportunities for having bad internet, for a potential answer being mistyped, or you not having enough time to fully type out what you want to say and how you want to express your answers. I just feel like it's a bigger challenge. All right, what I'm going to do right now, and those of you in class right now, we can do this in our after hours, so don't worry about it. But everybody at Zoom, I'm going to send you a link right now, and it's this survey, and it asks you which exam do you want, and then it has you fill out your first and last name and your student ID. So I'll just send this to you quick, as soon as I can find it. And let's take just a minute to fill this out. If you have questions and you're not sure yet, you don't have to fill it out right now, but you'll have to make sure you talk to me and get this link later on then, so we can fill that out. So check the chat. Oh, you need permission. Ooh. Okay. I don't have... Interesting. Okay, let's hold off on that. I didn't create the survey. Oh, Kaylee was able to get it. I think you definitely have to be on a ISD 622 account. So if you're not, for some reason, if you don't open it up and it's not on your ISD 622 account, then you probably won't be able to open it up. So if you can get it, fill it out. If you can't, we'll come back to it. I'm going to see why I don't have access to edit that. So all right, and like I said, I didn't create this, so I don't have the ability to change the access to it. Yeah, if you need permission, let me talk to the person that created it. So we'll hold off. If you can fill it out, great. I'll remind you again next week to do this. Okay, so we're going to shift gears here. And good news is we're doing something similar to what we did on Monday. However, it's a little bit trickier, or it can get just a little more complicated, so we're building off of that skill. Officially, if we're following through in our textbook, this is 7.2 day 1. And look at the title, Separable Differential Equations. That's a key word, separable. What does it mean? Well, to separate. We have to separate, so we have to separate x's and y's together. So anything that has a y needs to be over on the other side with dy. Anything that has an x needs to be with the side that says dx. And that's the big goal for today. Alyssa, I just got that. I will post a video in the classroom, so you can watch that when you're done. Thanks for letting me know. So, our goal is to solve the differential equation, which, when they say solve, we just have to find the general solution. So we have to put the plus c. Well, this one's a little bit tricky, because I have x times y squared. The first thing I need to do is, because it's a multiplication, I can square each piece individually. So I just rewrote this so it's a little bit friendlier. But we still have a problem. We still have x's and y's on the same side. So what I need to do is I'm going to officially divide by the y squared. So I'll get 1 over y squared. And that's, notice I'm bringing that over to the other side with the dy. And then the dx is going to be brought over to the side with the x. That's the new part. That's the separation part that we have. Really, that's the only new thing today, is that separation, getting x's and y's on the same side. So now that we have that, to solve differential equations, we do the antiderivative, or the integral. Now, the format here might not be perfect, or you might not love the way that this is written. Maybe I'll just rewrite it. Anytime I see a fraction that is like y squared is on the bottom, I rewrite it so it's y to the negative 2. And now it's just some antiderivatives. So notice, it's kind of like adding an extra problem. Now we have something to solve on the left side as well as the right side. So what do? We follow our undoing of the product rule, or power rule, excuse me. I'm going to add 1 up top, so that gives me y to the negative 1. But if I have y to the negative 1, I have to compensate, and we're going to put a negative 1 out in front. Over on the other side, we're going to add 1 as well. So that'll give me x is a third, but if I put a 3 up top, we got to put a third out there, and then we put the plus c. Now you might be wondering, why did I not put a plus c on this side? Well, we technically could have put a plus c. Don't write this. But if I put a plus c here, this c stands for constant. But it's not guaranteed to be the same constant here. So if I move this constant over with this one, I can still just think of c as being a constant. I know it's kind of weird to think of, but by putting 1c, it kind of just simplifies our life a little bit. All right? Now, we're not technically done, because it says find the general solution, which we have. But notice how it's not equal to y. So now we're going to solve for y. So algebraically, I'm going to divide by negative 1 first. And let's see if you guys are okay with this step. Now, technically, this c is just a constant, right? Constant means it could be any number. So if I times it by a negative 1, it's still going to be a c. That c kind of absorbs the negative, in a sense, because c stands for constant. I'm trying to think if they would give you credit if you put minus c or not. I believe they would, because the sign really doesn't matter for the c value. But notice how I put 1 over y. Well, where did that come from? That came from this negative 1. So I did kind of 2 steps in one. But I don't have y by itself right now. What I have is 1 over y. So you can always do this. I can always take one complete side and divide it by 1. And now we can just flip both sides. So instead of 1 over y, if I flip it and make it y over 1, then the whole other side is going to be just flipped upside down. That's taking the reciprocal of both sides. And there's my general solution. Now, I showed you this process without really going through a step-by-step process for this, and I did that on purpose, because I just wanted you to kind of get the general flow. You don't have to write these problems. I just want to show you a couple of things. Actually, you know what? It might be nice to write this next piece, but it's this part that you don't have to write. Sorry, let me give myself more space. Now that we know the general solution, it's going to tell us to use the point 1, 1 to find the particular solution. which just means find C. Use the point 1, 1 to find the value of C. So that part shouldn't be anything new, because we did all that yesterday. If x is 1 and y is 1, we're going to find C and then use, then once we have that, we can find the answer 1.2. So what I'm going to do is say, let's plug in 1 for x, 1 for y, do some simplifying, and then whatever's left over is our C. And we're going to get creative when we solve this too, so it's kind of a fun way to look at it. So I know that 1 to the third power is 1, and then I've got minus 1, negative 1/3 plus C on the bottom. So how do I solve a problem like this? Well, let's make the left side a fraction as well. And now we're just going to cross multiply. And it's really friendly because they're all 1s. If I cross multiply, kind of running out of room. When I cross multiply, I get negative 1/3 plus C equals, cross multiply the other way, 1 times 1. And then I'm really thinking of this 1, not really thinking of it as 1, I'm thinking of it as 3 over 3, because I know I'm going to add 1/3 over to the other side, so then that will be C equals 4/3. Now, I could call this y, right? So if I plug C back into the general solution, I could call it y, but I can also call it f of x. And that's important for us to understand that those two are kind of interchangeable. Because now that I have the particular solution, then I can use it to find anything that I want. And that's what they're asking for right here, is now that you have the particular solution, then find the value of 1.2. So we would just plug in 1.2. This is not super friendly, so at this point I would grab my calculator and just do that. I'll do it really quick here. And like I said, this is not super friendly. I didn't pick a great number here. But if I do this, I'll get a decimal answer. If I turn it back into a fraction, there is the value at 1.2. Most likely, this all would be a no calculator question, and then this value would be something much friendlier so you could actually do it. All right, I don't know if this is, I put it on here. It's actually going to lead us into what we're doing next week. So I just threw it in here because it's not a bad time to talk about it. Well, what did we kind of really just do? We took this differential equation and we analyzed its slope at the point 1, 1. So right here, we were able to look at the value of that, and this is the point 1, 1. Now, if you look at this, this is called a slope field. And I just want you to be aware of it. You don't have to understand it in full depth because that's what we're going to cover next week. But what it is it's the slope at every single point. So if you look, this slope here looks to be close to 1. Right? It looks like it's a positive 1, up 1, over 1, up 1, over 1 will get me that slope. And I know that if I look at this location right here, if I go over -2 up 0, its slope would be 0. What happens if I plug in -2 here and 0 here? I get 0, and 0 squared equals 0. So all the work we did with this equation, if you look at every single different point on here could have a different slope. And if we graph just a little bit of those slopes, it creates what's called a slope field. And then what we did was we have, now you guys won't really understand this right now, but this is roughly what this function right here, our particular solution, if I was to graph it, it would kind of look like that, roughly. Well, look at this answer. We approximated at 1.2, which is slightly off here, and this was a tangent line approximation. So we would have, our graph would be an underestimation right now at 1.2 versus what the actual graph would be. Like I said, I'm just painting the picture. If you kind of see where things come from, that's cool. If not, we're going to fully cover this on Monday. So, what did we just do? These are the steps if you want to write them down, but to be honest, they come kind of naturally once we do a bunch of these problems. So what did we do? Well, first thing we have to do is we have to write the derivative as a differential. What that first step means is if I had it written as y prime, that's not a differential. That's just called y prime. To write it as a differential, we would call that dy dx. And the reason why it needs to be written as dy dx is so you can separate the variables. That's the important piece. Right? How do we separate variables? You have to separate the x from the y's. So the x's belong with the dx's, the y's belong with the dy's. And most of the time, it's some form of algebra. Multiply or divide to move it over to the other side. Every once in a while, we might have to cross multiply. But technically, those are the same thing. Step 3 is once you have the variables separated, then you're going to integrate. Remember, that's the integral. Right? Integrate both sides, and don't forget to put the plus c, because the plus c is very important. And then we got to solve for y, so we get our general solution. But if they give us a point, then we use that point to find the particular solution, so we find c. This is a major concept in calculus, and I will almost guarantee with close to 100% certainty that you're going to see a free response question like this that'll most likely be no calculator on the AP test. You might even see 2 of them. Sometimes you have to do this more than once. Okay, so our job today is just to get used to this process. Look at right away, before you even start writing, look at the differential, dy dx. So that's written in the correct spot. The problem is we have y's and x's on the same side. So we need to separate the x's and y's. Okay? And then they do give us an initial condition, which means we're going to find c, and then we're going to find exactly what c is equal to. All right. So it's important for when we are solving for y. Notice how dy is on top, and almost all the times, unless we switch the variables, dy will always be on top. So you need to keep dy on this side, which means I need to move a y over to the other side. So how do I get rid of a y that's on top? I'm going to divide both sides by y, or in this case, times by the reciprocal 1 over y. So what does that do for the left side? That leaves me with 1 over y dy. And then technically, and it's more notation-wise, I would probably get yelled at by calculus people if I told you we're really multiplying the other side by dx. We're not really, but we're just bringing this dx to say we need to differentiate x on this side. Well, notice where the x originally was. It's in the denominator. So one of the bigger mistakes is students sometimes move the y over correctly, and then they think just an x squared is left over. Well, that's not true. It's 1 over x squared. So be very, very careful on that. And now I'm at the point where I can take the integral. All right. You notice how the y's are together with dy and the x's are with dx's? That's what the separation of variables is possible. And this one is really friendly. Whose derivative gives me 1 over y? The log. Right. So that's just knowing your antiderivative facts. This one here, I like to think of it written as x to the negative 2. And then I'm going to undo the power rule. So I'm going to add 1. So this will be x to the negative 1. But if I put a negative 1 up top, I'm officially dividing by a negative 1 or times it by a negative 1. Same thing. And there's my plus c. Now, here's a hint. As soon as you see the c appear, notice this isn't equal to y yet. Don't do any algebra. But as soon as you see that c appear, we're going to use the initial condition. We're going to use x equals negative 1 and y equals e to find c. It will get harder or more challenging if you were to solve for y right now. So that's why we want to just plug in what we know and find c. And it's going to be a lot of kind of exponent properties and extra stuff here. So let's plug in e, and then we'll plug in negative 1. Sometimes this is really friendly, sometimes it's a little more challenging. Keep in mind this is e to the first power, because the natural log and e, those are inverses, so they're going to go away. And all I'm left with is 1 on this side. And then negative 1 to the negative first power, well, that's like doing 1 over negative 1. But then I've got a negative 1 times that, which is really just a positive 1. So all of that simplifies down to 1 plus c. And then just move the 1 over. And we get c is equal to 0. Well, now that we found c, we go right back to the spot where c was first found or discovered. And we're going to plug in c. In this case, it's 0, so you don't need to write that. And then, once you plug it in, our very last step is to solve for y. To do whatever algebra we need to do In this case, all I need to do is get rid of the natural log. Those absolute value bars are going to come into play, and we'll talk about that in just a second, but what I'm going to do is I'm going to take the entire left side and right side, I'm going to raise it to the power of e. And then the natural log and e go away. So I'm left with the absolute value of y. And I know I put 0 in here for a reason. I want to show you this property so we become really used to it. But remember, if I didn't write that 0, I'd get the same answer. But remember the property that we talked about the other day? Where if I have e to the 2 exponents being added together, I can split that up as e to the negative 1, x to the negative 1 times e to the 0. So that's an important property. And the reason why I show you that is, well, wait a minute, this 0 shouldn't matter, right? And it doesn't, because what is e to the 0 power? Anything to the 0 power is 1. So, if it was something other than 1, we would write that 1 out in front. And then it would be e, and most likely, your exponent, negative 1 to x to the negative 1, will be written this way with x in the denominator. Now, the big question is, what happens to the absolute value bars? How do I know if the answer is going to be positive or negative? Because if my answer was y, y could be positive or negative, so it depends on this original condition. Notice, e has to be a positive e. So if I plug in negative 1, you don't have to write this. It's just more showing you. What if I plug in negative 1 right here, and then I simplify? That becomes negative 1 over negative 1, which is positive 1, which becomes e. So notice, y is equal to the absolute value of e. If for some reason this answer was negative, I wouldn't be able to get a negative here, so I'd have to compensate for that. Since this is a positive number, then we know that this value has to be the positive side of it. And you might not be perfectly comfortable with that, but as we learn more about it, you'll get used to why or how we use the initial condition to check the sound out. And again, you don't need that 1 there, but there it is. We solved the specific value. I don't think we're there yet. Let's do this one. So as you're writing the directions, you can see it says find the general solution. So you should know automatically, just from that word general, your answer is going to have a plus c. Notice how this doesn't have that differential in it. It has y prime. So what we need to do is we need to see that y prime and think of it as a quantity dy over dx. And that's what it will allow us to separate the variables, the x's and y's. Alright, so the next thing is you don't have to show any work to separate this, but notice how it's a times by y to the third. I'm going to move it over to the other side with division. And then the 5x squared is going to stay, and the dx is going to move over, so my x's are with my x's, my y's are with my y's. And you're always going to keep the dy on the left side. Alright? So now, There we go. It's just doing two different antiderivatives now. If you want, you can definitely save yourself some time and space. I like to write the y to the third with a negative power instead of 1 over y to the third. So why don't you guys go ahead and find each antiderivative of the left and right side. So if you do the antiderivative of each side, these are just undoing the power rule. So I'm going to add 1 up top. So I'll put a negative 2 up top for the y. But if I put a negative 2 up top, I have to compensate for that and put a negative 1/2 out front. And then if I have 5x squared, I'm going to add 1 to the 2, so it'll be 5x to the third. But if I put a 3 up top, I have to divide by 3. Now technically, we're not done. If you were to check your textbook, it would stop there. But we want to solve for y now. And it's just algebra. So first thing I'm going to do is get rid of this negative 1/2. I'm going to times both sides by negative 2. And as I write this, I have that y to the negative 2. I'm going to rewrite that as 1 over y squared. And then I'll multiply. Now here's the weird part. We don't really call this 2c. It's just c, right? C is a constant. If I double a constant, it's still a constant. And so we can just still call it c. And then we run into that same problem we had on the last example. We have 1 over y squared. I don't like that. So I want to just flip the reciprocal of both sides. So this will be y squared over 1, and then 1 over n thirds x to the third plus c. And now it's much easier to get rid of the square root. Now notice, we didn't have an initial condition. They didn't tell me, here's the point that I have to have. Which means I don't know if my answer is going to be positive or negative when I take the square root, so we do have to put the plus and minus. Which one would we use? It depends on what the given point would be. All right, so if x was 0, then I would have the positive version, because this would end up being, depending on what c is. But we don't have that point, so we're not going to go further than that. But there's my general solution.
Would 10 times be negative since it is negative 2?
Oh, shoot. Good catch. Thank you. Yes, I forgot that negative. That would be a negative 10 thirds, negative 10 thirds, negative 10 thirds. Thank you. All right. I want to see. I don't think we'll get through all of these. I keep saving that one for later. Which one's better? Let's do this one. Differential equations can exist when you have trig functions as well. Any function can be used for separable differential equations. And we'll do this one together because there's potentially a little trick here. Let me see. I actually don't think I want that squared. Do I want the squared? I don't. Get rid of that squared. I don't know. Yeah, this will be much friendlier. Okay, so what do we need to do? We need to separate. So I need to, anything with a y needs to be moved over. So you don't have to show this step. You can just say, yeah, let's just move it over. So 1 over sine y, 1 over x, yes. I like the spacing there. Trying to think if I wanted that squared there. That's what it was. Shoot, I mistyped this one. Let's do this. I wanted this. I think this should be flipped. Right now it's not friendly. 1 over sine, we can't take the antiderivative of that. So sorry guys. That's what I wanted. After you just wrote all that and change it twice, we'll change it a third time. Okay, so this one, notice how the y is on the bottom? Sine of y. I need to move that over to the other side. So I'm going to times both sides by sine of y. So that brings the sine of y nicely friendly over to the x, and now the x is actually on top. And then we can take the antiderivative. So we're thinking whose derivative gives me sine of y, and then whose derivative gives me x. So fairly quick, friendly ones. The antiderivative of sine is negative cosine. Remember the negative, because if I was to take the derivative of this, I would get back to where it started. And then this would be antiderivative of x is 1/2 x squared plus c. So now we got to solve for y, which means I first have to take care of that negative. And again, the negative is kind of absorbed into that c. And then the last step is I need to get rid of the cosine. You can't divide, right? You can't just divide by cosine because that would bring the y with it. You need to move the cosine over to the other side And you could either say cosine inverse plus c, and notice how the plus c is in the parentheses as well, that's important. Or we could use the word arc cosine. Just remember those are the same thing. So hopefully we've done enough of these where the process seems pretty decent. I will say they're challenging. There are some that are really friendly. This would be one that I'd say is pretty friendly. There are ones that are going to be tough. And don't forget that u substitution is potentially something that you might need to do an integral. We'll do more of that next week with u substitution. I want to make one quick disclaimer here, and I don't want you to write this. This is just a kind of a quick thing. How do we handle discontinuity in initial value problems? And I know right now you're thinking, probably like, I don't understand what that means at all. But what if a solution curve is continuous? Then the initial condition pins down the solution over the entire domain. So if it's continuous, we don't have to worry about anything. But what if it's not? What if it's discontinuous? What if there's a break and there's like 3 parts to a graph? And I find a particular solution. Well, if the solution curve is discontinuous, the initial condition only pins down the continuous piece that passes through the given point, which means the domain must be specified. Let me show you what all this means, just with a quick example. And again, I'm not expecting you to write this. I actually picked one that was kind of friendly. So notice my dy dx. There aren't any y's. So I don't have to officially separate other than just moving and doing the antiderivative with respect to x on this side. So I still thought about separating, but we're going to go ahead and take the antiderivative, which is y. This is x squared. And there would be a 2 here, but I divide by 2, so this 2 and the divide by 2 cancel out. And then whose derivative gives me secant squared? That's just tangent plus c. And it gives me the point, right? xy. So I would go ahead and plug in 3 and 0, or the x's. The nice thing is tangent of 0 is 0, so that means 3 equals c. So what do I get as a final answer? Right there. Okay. Now, what we talked about though is this graph is actually 3 separate pieces. And that's what's important for you to understand is I have 3 separate pieces to this graph, but since this has the point 0, 3, so if I go over 0 up 3, here's the only part of the solution that is true, which means we cannot say that the derivative, the dy dx, is going to work for any part that is not physically connected to the given point. So, if you have a graph, and it's kind of challenging, you have to know a little bit about the tangent graph to know where the domain would be. So, in this case, the domain for this function would be anything between pi and pi over 2. The reason why I bring that up is if it's a multiple choice question and they have this answer written down 2 or 3 times, they're going to have a different domain attached to it. And you'll just have to think of it graphically. If you're allowed to use your calculator, graph this function, and then just know, read the domain from that function. Okay? This will come up a little bit later. So, what we got tonight is 7.2 day 1 homework. It's not a ton of problems. The big thing you do have to remember is to separate the variables. If you don't separate the x's and y's, everything else will be incorrect. The answers are in Schoology, so hopefully you're going to check those as you go along. Jacob, I'll answer your question in a second as soon as I jump back. I also just got feedback from Miss Trevette. Anybody that tried to open that link, you have to open up the link using your school email address, which means if you open it up, double check that the browser you're on is connected to your ISD 622 email. If it's connected to a different email, it won't open. Okay, so Jacob, you had a question. How come it's not a 1/2 x squared here? And the reason why is there was already a 2 there. So if I put a 2 and then a divide by 2, a 2 over 2 would turn into 1. So that's why this part, the 1/2, it was not written. Even though your thinking is correct, it had that original 2 to reduce out. All right, anybody at Zoom, if you have questions or need help, I will be available from 12:55 to 1:30. I'm going to help the students in the classroom, but if you want to join our Zoom, you can do that as well. And I actually added this to our class, just so you're aware. So I call them office hours. Oh boy, not my wife. This link will allow you to join any day, Monday through Thursday. So if you don't have calculus that day, feel free to join in. You can just join into my other calculus class because I have calculus at the same hour every day. So, all right, that's all.